Okay, awesome. All right, good morning, everyone. Thank you again for joining us. My name is Sarah Husky with 3C Ren. I've started recording this course and it will be posted on our on-demand page. Today we have Jennifer Rennick and Paul Dunn with us to walk us through HERS measures for energy code compliance. But before we get into that, I just have a few slides to run through. Just really briefly, we just ask that everyone stay on mute. And if you have a question, please feel free to unmute yourself or raise your hand. We'll also be monitoring the chat box as well.
Roll. Hi. Okay, I'm in a meeting.
All right, so a few words about us. 3C Ren, we're the Tri-County Regional Energy Network. We're a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren currently offers 3 programs. Go to the next slide, perfect. The first program is our Energy Code Connect, which this course today is brought to you through. This program serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. And we have our Energy Code Coach service through this program, which is an over-the-phone, online, and in the field support for residential and non-residential Title 24 questions. And our next program is our building performance training, which serves building professionals by offering technical and soft skill trainings related to building science principles, high performance buildings, marketing, and communication techniques. And then we have our home energy savings program, which incentivizes contractors and helps residents save money to make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Jennifer.
Hi, everybody. Thanks for joining us. Let's see. If we end up with a small crowd today, feel free to, unmute or ask a question, or at least put something in the chat, and then Sarah will see that and can stop us, and we can have a better discussion about some of the slides. And just kind of let you know, we've got learning units for today's course through the AIA and also through the ICC. And today's focus is really going to be on the envelope and quality installation, QII, and kind of the process for checking for building air leakage. And then a lot of the other HERS measures we will be hitting on our part 2 course. So today is the kind of the part 1. So part of HERS measures for single family and low-rise multifamily construction is a process of, we show compliance first, then we need to show that whatever we had put in those compliance documents to show that we met the energy code is installed properly. And then the third part of that process is that we have a verification that the installer installed those things to meet those installation requirements. So on the single family side, we have our CF1R form, which is often called our Title 24 report. And then we've got our CF2R forms and CF3R forms, which deal with the installation requirements and the verification requirements of those items installed. And those are the 2 forms that Paul usually works on. Oh, I should back up. My gosh, I didn't really introduce myself or introduce Paul. We just kind of went in on it. And then Sarah didn't really say that much either. You two should have stopped me. Okay, back up. Jennifer Reddick, I'm an architect and a certified energy analyst. So in my world, I'm dealing a lot with that CF1R form. And then I'm joined by Paul, who is a HERS 1 and HERS 2 rater, BP analyst, and is dealing with the in the field verification testing, and collecting those verification forms sometimes on the builder's behalf. Sometimes Paul can jump in, but
Yeah.
Paul's mostly going to be taking care of the CF2R and the CF3R forms in this process. Okay.
Okay.
So
Good morning, everyone. Right. Yeah. Just a little bit about me. I've been a HERS rater since the 2005 code. So that had me out in the field starting around 2007. And so I've been marching forward with each code change until now. So I've conducted over 3,000 duct leakage tests, done QII on probably 500 dwellings plus, and boy, probably a couple hundred blower door tests and so on. And we'll get to all that as we go forward in today's webinar.
okay, thanks. Okay, so kind of back now to sort of the overview for the forms for residential, single family, and low-rise multifamily construction. Just kind of reviewed those basic forms on the single family, which includes duplexes and townhouses side. And then on the low-rise multifamily side, which low-rise 3 stories or less, so new under the 2022 Energy Code, is a different set of forms. So now we have a LMCC for low-rise multifamily compliance forms. And that, again, that would be kind of the realm I work in most of the time. And then the LMCI and LMCV forms, which will deal with the installation requirements and the verification requirements of those energy features. We will address a little bit about where the California Energy Commission stands with those multifamily forms as we kind of go through this. But kind of big, another sort of big picture is that these forms do have to be registered with a home energy rating provider, and HERS stands for Home Energy Rating System. And Paul is a HERS rater, so Home Energy Rating Rater, I guess is what you call it, rating system rater. And right now in California, we have 2 HERS providers, CalCerts and Cheers. And these organizations, they're basically responsible for the training and the certifying of the HERS raters, and they support the California Energy Commission with the HERS registry. So many of us, if you've already been working on single family residences in California, you're probably familiar with the HERS and HERS raters and that HERS registry. However, new in 2022 Energy Code, the California Energy Commission pulled the multifamily portion of the building code out of that section, out of the single family section of the code. Multifamily now has its own section and kind of its own set of forms. And so as of now, there's not a up and running HERS registry yet for low-rise multifamily projects. So technically you would follow this path, this process I'm going to lay out, but it's not on board yet. So there's a couple little workarounds that we'll talk about. But when this gets set up, the process is supposed to be the same. So you basically are going to start out, with your project. You have a design submittal to your planning building department, that it goes through construction, that you get your final and your occupancy. And so that CF1R compliance form, it's created and it's uploaded to the HERS registry. And then during construction, those CF2Rs are installed and completed, also uploaded to the HERS registry, and the CF3R verification completed, also part of or uploaded into the HERS registry. And then the final, the occupancy, your building official confirms that those CF2Rs and CF3Rs are uploaded and signed, and then they look for something called a PSR, which we're going to get to in just the next couple of slides. In order for you to get an idea of what these forms look like, because one of the things I found, even as an energy analyst doing the CF1R side of things, the Title 24 report side of things, it's hard for me to even look at a project and see what is the CF2R and CF3Rs coming into place. So what I do is I go into the California Energy Commission website and I take a look at the forms so that I have a draft copy and really have a better understanding of what they are. And so if you go into that if you go onto the California website, you can navigate to this page. This is the page for forms residential, and you can click the plus mark and it's going to open up and give you a list of all the forms. And I'll show you what that looks like in just a moment. And then kind of an aside, you're going to get a copy of the slides, by the way, but I just want to make a little note here that most of the forms that we're going to see, they're for reference only. And so those forms, you know, you'll eventually get a watermarked copy that's registered with the HERS provider. And for the multifamily forms right now, one of those workarounds is that for prescriptive compliance, you can have a form-filled PDF through Energy Code ACE. And according to Energy Code ACE, the performance method forms are quote unquote coming soon. Then they're talking about those CF, or what would be equivalent to the CF2R, CF3R. So it'll be the LM, CI, and CV forms. Meanwhile, your energy analysts can just use the software, either Energy Pro or use the state software, and create a performance Title 24 report for you. It just won't have the watermark on it at this time. So when you click open the envelope section, you're going to see a list of the supporting documents. And today, there's quite a few of them, but today we're going to kind of hone in on the installation, the QII, which is quality installation forms. And then we'll take a little look at what the building envelope air leakage diagnostic testing looks like. And there's some CF2R and CF3 forms that go with that. And kind of as a reminder, if you go in and take a look at this list, or even when you're looking at the forms, if you see an E at the end of that form designation, the E stands for enforcement agency and the H is for the HERS. And not all of them have an H after them. Like, for example, the CF3R envelope 20-A, the building enclosure diagnostic testing, but only your HERS rater could do that test anyway. So, but for the most part, you'll either see a H or they'll actually spell out a HERS after it. And Paul, jump in on any of this stuff if you think I've this is kind of the boring stuff. I think it's a little boring, but it's necessary to understand this. And
Sure.
then after we go through this, then we'll get to the part with the pictures, and Paul can really jump in on what he's looking for and what he does. And then we could talk more about from how do you, you know, what you need to do with the architect, the installer, the builder, and the HERS rater, and getting your
people want to hear
all
war
this to
stories,
go through.
right?
Yeah.
Yeah.
And now, okay, so for the multifamily project, so the LM for low-rise multifamily CI and CV forms, you can take a look at that. And we've got QII forms, quality installation for both the certificates of installation and the certificates of verification. However, if you're wanting to know more about air leakage testing for multifamily, it just so happens that the air leakage testing is part of the mechanical section. And it specifically would look at the LMCI or CV MEC 27, MCH 27, and 24H forms. Today, we're going to focus on the envelope forms. So when you go into the CalCerts website, and they have something similar on Cheers, but I'm most familiar with CalCert, so I'll address this as an example. You're going to see a list for a given project. You'll see a list of CF2R and CF3R forms. And then along with that list, you'll see those envelope or those MEC or your plumbing, battery storage system, et cetera, et cetera. And these are the possible forms that could be triggered. And then you're going to have the two columns that says, yes, the certificate's needed, or no, or it's not applicable. And this will give you an idea as the architect or, you know, have your energy consultant just double check on this stuff if you want to know what forms are being triggered by their energy analysis. So after those CF2Rs and CF3Rs are complete, the project can obtain the final occupancy. So kind of this big picture is that get the CF1R on the HERS registry, CF2R on the HERS registry, CF3R on the HERS registry, and now the enforcement agency, or AHJ, often heard, authority having jurisdiction. So your planning and building department folks can access those watermarked forms. And what they really want to know is if everything that you have to do is a pass. And you can see on this slide, the watermark will show up, like in this example, as a CalCerts ink with the star across the pages. And if it doesn't have that on it, it hasn't been uploaded and gone through the proper HERS registry, except for multifamily, low rise. They haven't gotten there yet. So you'll still see, if you're an authority having jurisdiction or an architect getting those forms, you're still going to see just forms that say not, you know, draft, not registered, but you will have to accept them anyway until the HERS registries are set up. So the authority having jurisdiction, once they go into CalCerts or Cheers, they're going to be looking for the PSR, which is the project status report, to show compliance. And what they're really looking for, and we've heard it in our office, is, hey, at the job site, they just want to see the green dots or the green check marks. And so they're looking for this part online for everything to be checked, that it's complete.
And so if I can just jump in,
yes,
to the builders in our audience, either you as the builder or your individual subs are responsible for their CF2Rs in residential construction. A lot of installers are not savvy with the forms that are uploaded. So you as a builder, if you have staff that can supersede that or kind of approve above your subs, you're allowed to do so, at least in both of the registries. Oftentimes, myself as a rater, I will upload the 2Rs on behalf of you, and then you will have to have the responsibility to approve those uploads in due course so that we can complete the circle. That's my input for that.
Right. And yeah, sometimes there's a project we're all working on together, and yeah, the authority having jurisdiction just kept showing like the screen on the iPad, basically saying, hey, I just want to see these check marks here. And
right.
the builder's like, okay, but what the heck does that actually mean? What am I missing? What is, you know, what really needs to happen? And that's where you need to, you know, coordinate with folks early on. So this next slide, we're going to kind of go through that and kind of show that a lot of this really works best as like a team sport. So this flow process is that you're going to have your architect and work with the energy consultant, and they're going to need to coordinate and have a CF1R document that shows that that design meets the energy code. And so on that, a lot of times we're doing a performance method, a computer energy model. And on that form, there's going to be a HERS feature summary that will show anyone who reads that report what kind of HERS measures are being triggered. So in this example, quality insulation installation is being triggered. And it's worthwhile to note that QII is prescriptively required if you're going to comply using the prescriptive, and which is like a recipe card. You follow all the pieces, all the food ingredients on the recipe. You're not doing a custom chef special right now. It's just you're following the recipe. You got to do everything. And in that recipe, QII is now a requirement under 2022 Energy Code. So if you do the performance method, you could trade off not to have to do QII, but a lot of times, since it's prescriptively required and your project's going to get compared to doing QII, we're seeing QII is just on a lot of jobs. So hence like this class, and hence all of us talking about it. So this workflow is that the QII is triggered on that CF1R, and then Paul's going to jump in here in a second, but basically you're going to want a job site meeting to review all those requirements, because there is some coordination. And really the bulk of the slides now is going to talk a lot about what kind of goes into that. And there's going to be HERS inspection and these forms filled out at the framing stage and at the insulation install stage at the minimum. And they're going to be looking at your envelope measures and your HVAC duct measures, which we'll hit more on that in part 2, and your all your installation envelope measures.
Yeah,
Okay,
so
Paul.
what's important is that the key in the performance pathway, quality installation of insulation is a deep credit. So it is also a pretty hefty checklist for us raters to go through, and for the installers as well. So that's kind of the bulk of the next of these slides that we're going to be going through, is some of the things to watch out for and things you need to plan for at your initial job site meeting, or at least some kind of kickoff meeting, so that everyone's on the same page with what we're regarding all the checklist items that we have to go through.
Yeah, and then I think, Paul, you had pointed out in our previous discussions, I think it's good that I remind folks that the California Energy Commission, really big picture, they put a lot of weight into the envelope, into the building assemblies for conserving energy. So
Yes.
how those walls are constructed, how the roof and attic is constructed, how your doors and windows and all the penetrations are air sealed, all of that is really forward up front in terms of energy savings in buildings, which is tiny part of the real big picture of where California is going in terms of conserving energy, because it means that the state does not have to build huge new power plants if we can just conserve and more wisely use the energy that we're already able to create with our existing infrastructure. Not including adding renewables to that portfolio.
Yes.
So air sealing, QII, framing stage for low-rise multifamily, those forms are basically similar to the single family forms, except there's some items specifically describing where assemblies must be sealed to stop the air movement between dwellings. And also this form, it more explicitly spells out what air barrier materials, in terms of like the actual technical requirements, can be used for air barriers. And if in multifamily, it's not unheard of to use alternative materials. And so you can also show this by doing the building air leakage envelope testing, not to exceed a certain amount. And that way, if you use some materials that maybe don't meet this air barrier material specifically, you could do the testing as another way of doing that. And then some of these air barrier requirements of multifamily dwellings that's called out a little more specifically than on the CF2R forms is that each dwelling unit is treated kind of like its own cell and self-contained. And a dwelling unit to its right, to its left, above it, below it, or a common hallway along the pathway, each of those other elements are basically to be treated as exterior. So now in between dwellings and from a dwelling to a hallway, all of those penetrations, all those wall assemblies, they need to be air sealed and insulated as if they were to the exterior, then to stop the air movement between dwellings. Paul, you want to jump in here and add anything on that?
Well, I just want to say that's, that should make sense to everyone that, if you have technically an unconditioned hallway, it's the wall separating that hallway to the dwelling unit is considered an exterior wall. So, but sometimes in multifamily, you'll see those hallways being kind of passively conditioned with some kind of ventilation system, which is not really providing heating or cooling energy. It's just a way to introduce fresh air into those areas. But we are considering those unconditioned spaces. So those walls, again, separating that between the hallway and the dwelling is an exterior wall in that instance. Pretty common.
Yeah, and as well as like your elevator shafts, if you have them, or garbage chutes, or any other your mechanical shafts, those also need to be air sealed and treated separately.
Right.
Okay. So the kind of the big picture form for the insulation installation, this doesn't have, it's got an E after the name. It's the enforcement agency really comes into play here, not the HERS rater, but everything that's in these forms, really it's part of the mandatory measures for the energy code. And all of these mandatory measures have to be met in order to meet the QII HERS testing anyway. So they these requirements roll right into all the stuff that Paul's going to talk about. And so if you were to take a look at this, download this form off the California Energy Commission website, you can get a form fillable portion of that. That's the first half, and then that second half of the form is going to be a list of reminders for those mandatory measures and other things. So for example, in that field description, it specifically spells out no gaps or voids between the insulation and the framing, no gaps between the sides or ends of bad insulation, et cetera, et cetera. And this is just a good, if you're not familiar with the forms, it's a good reminder to take a look at this so you could see what is going to be addressed.
It's interesting to note that most of these items are right there on the bags that bat insulation is sold. So you go to a job site and you're looking at the actual, plastic wrap, and it's got basically a list of how to install the material. Granted, bat insulation takes more effort. You've got to have a sharp bat knife. You got to, cut that bat if need be to fill that cavity just perfectly. And it's going to take a little more time and attention to detail to meet the level of the quality that you're after for a thermally effective envelope. Next.
That's right. Okay, here's one that, okay, so here, this is a mandatory measure and it's part of QII also, but specifically, it spells out that insulation is to be cut around obstacles such as electric boxes. And bat insulation is has to have a process of where you delaminate it, they call, or pull the bat, kind of split it in half up through its middle enough to put some of the bat behind electrical wires and some of the bat in front of electrical wires. So, Paul, I'll let you address these photos because Paul says,
Sure.
pass on the left, fail on the right. That was what he said when I showed him the pictures.
Well, if
Like,
you go to a
okay,
job
perfect
and you see,
example.
you go to a project and you see bare Romex in a cavity like that, something's missing. And you can see we've got a detail there that shows, you know, it's not really sandwiched. Insulation is only going to do its job when it's trapping air. And it has to have, basically, I tell my my builders, we're trying to make a sandwich here, like a ice cream sandwich where the insulation's in the middle and it's trapped between two approved air barriers. And we don't want to have any of the big three gaps, voids, and compressions. So on the right, you certainly have a distinctive void there that would not pass QII. Easy fix, we just need to have some more insulation added to the cavity to bring it up to the level you see on the left there. So that when the drywall goes on, it's in substantial contact with the insulation.
Yeah, and then in a stark contrast to the one on the left, take a look at these shots from some recent jobs, some jobs of ours, and I know for sure the job on the right was fixed, but I don't know about the other two on the left.
Right.
I would hope they got fixed. I'm gonna let Paul address this
So
part.
when you go to your first inspection, say, and the installer did not bring their A team, because I have found, at least locally in San Luis County and Santa Barbara County, there are certain installers that have a number of teams that go out to the various job sites, and some are better than others. And so you have to work with them to, at the site, I like to show up the day they're doing it and, you know, work side by side with them sometime to kind of teach them what they need to do so that when I come back the next time, it's, you know, it's going to pass QII. So here I am, you know, just explaining to them, you know, what needs to happen so we can get all six sides filling a cavity, and that insulation is substantially in contact with the approved air barriers and so on. And so I will just go along and show them with my own two hands what needs to happen to make this work for everyone. And it seems to succeed. So I build teams working with the installers so that we have kind of like everyone on the same page for what is going to meet the measures. But
What I
yeah,
know from the architects and the energy consultants side of things, if you don't know who the builder is ahead of time and you don't know kind of their preference or what materials they might be using, the Title 24 energy report is very, it's very generic. It might just call out bad insulation, or it might just call out a cavity filled insulation. And it's really going to be up to the builder to determine which product to use, but at least knowing ahead of time now, getting the word out that QII is most likely going to be required, then it's going to make a big difference kind of on their job if they know that going into it, and also so they can assess the skill set they have and the cost to maybe choose a different material. And these, this is a fiberglass and rock wool examples. And this next one is an example of a blown-in product. This one's blown-in cellulose, but you can also use blown-in fiberglass. And right away, a blown-in product, when they staple up that fine mesh to hold the material in place, they'll put a hole or several holes in that membrane, and they'll blow in the insulation, which is usually has a light adhesive on it, which stabilizes it to keep it from settling. But this way, they can see enough through that mesh, and you can blow in that insulation and lift. So you're not depending on just trying to do it all from the bottom or all from the top. And then when it's done, like everything gets filled. No voids, no gaps. It's already fitted, it'd already be fit around the electrical box for the most part. You can come back and fine tune that if you need to, but this can make it easy for QII.
I will
and as a
mention-
designer, you might have clients who would prefer to use cellulose materials and lower embodied energy materials. So this can be a win-win for them. Go ahead, Paul.
So yeah, raising hand here. This does require another skill set because there's an art to filling these cavities just right, because if you overfill, now you're making the drywall guys mad. Because they're going to have to put up their drywall onto this overly puffed cavity. So they have to ramp up to speed and learn how to do it just right. So they're meeting their R value, but they're also working with their drywall team so that everyone is happy.
Mm-hmm. Okay, and then when it comes to sort of those framing members that don't have the big cavities that are going to be filled with insulation, part of the QII at the framing stage is to make sure that all the air gaps are sealed. So specifically, it's called out that narrow cavities and around windows and doors are to be filled with an expanding foam that also air seals is a good way to do it. Anything you want to add on this one?
Well, they've done a good job here. So the term they like to use is minimally expansive foam. There's different colors, different brands, different types. Raider really doesn't care as long as that air is substantially being stopped at the exterior portion and that cavity is filled. So I think around this window, there could have been a little bit more orange foam around that window set there. But the intent is to stop the air. We don't want any micro cavities moving air around inside of framing assemblies. And also going back to the whole concept of QII, years ago, we figured out that an energy consultant that was, say, prescribing R13 in a 2x4 cavity, that was one thing in theory, but then the actual installer, if they're over compressing it, now it's performing more like R whatever, R11 and so on. So the idea here is that the actual installation is performing as modeled, that R19 is performing as R19, R21 is R21, and so on. And that's in your walls, and we'll get to the attic here in a few more slides. Yeah.
To that conversation, like as a designer and the sort of the team sport again, is architects working with the often working with your energy consultant, but a lot of times they don't. When it comes to custom residential, multifamily is probably a little different in my experience, but especially the custom residential, a lot of times the architect doesn't necessarily know what that final combination of assemblies are going to be, because so much of that is dependent on the builder. So a lot of times, and I've had this happen, where the homeowner, architect, builder come back and say, hey, we're going to use spray foam, for example. And the homeowner wants bigger windows after all. They changed their mind. So we're going to do a change order. We want more windows, and we're hoping we can use spray foam to offset that extra energy use due to those larger windows. And one of the things as an energy consultant we could do is, if we have the specs on that spray foam insulation, it might be that that particular brand has a higher R value than the default values that the California Energy Commission has set up. And if that's the case, we could take a credit for it. And in this case, in the performance method, we check a little box that says non-standard spray foam insulation requiring QII inspection. And now the spray foam gets thrown into the list of items that someone like Paul would check. And that's all good and well, as long as Paul or the rater gets the needed documentation of that material's R value from the installer. And then this is an example from a colleague's project that was using spray foam up in the cathedral roof assembly. And I just thought it was interesting that when it cures, the insulation is quite bumpy. It's not smooth, and the bumpiness is just the way it is. And so the HERS rater would have a special tool that could actually pierce through that, and then they would measure the depth of that insulation to see if it meets the R value, and also to make sure that, in this case for closed cell, that those bumps aren't exceeding a half an inch in depth difference.
It's pretty common for me to receive a cut sheet from the insulation installer that verifies their higher R value per inch. So it's not a huge deal. They've got all that literature at their fingertips because they're buying the product from their supplier. So it's a doable approach to
A doable credit if you need
yes.
it.
Yeah.
Right. And then it
Yep.
just kind of goes back to that team sport thing too, because a lot of times your energy consultant and your architect aren't looking at this particular credit unless they hear or you find out otherwise you need it, or sometimes the design needs it. So as an architect, if you need some extra credits, this might be one that you can ask your energy consultant about to get those bigger, better, larger view windows, for example. For existing, whoops, okay, hang on there, accidentally hit the hit the mouse there. Okay, so for existing HERS existing conditions and new construction, I'm going to let Paul talk a little bit about these two slides. And
Well, I want to say, number one, for those architects in the group here that are being approached by a client, they want to do an addition or an alteration. Hardly anyone around here seems to take credit for HERS existing conditions, which is folded into the CF1R. It provides a pretty substantial credit and provides a benefit to the consumer, the homeowner, and the architect and the Title 24 person of what is actually going on in the house. So it used to be, oh, we're just assuming a house built in a certain legacy had a certain level of R value in their attic. Oftentimes, what we thought was there isn't there. It could be better or worse. And insulation, decays over time. So looking at the left, once upon a time, this was probably, R11 insulation bats put up there. And now it's just kind of decayed down to some other R value, which is a fair assessment to give the potential to increase it by adding maybe some blown in as part of the project. And that's, the so-called low-hanging fruit too, is always in a HERS 2 energy audit style analysis. The first thing you add usually is attic insulation to improve your thermal performance. So in addition to the mouse droppings or whatever else up there, it gives the consumer an idea what is possible to improve their project. Over here on the right, this is kind of standard blown-in cellulose, taken from kind of a standard attic. Maybe I took that picture a couple of years ago. And good strategy is you don't have to suck out the old nasty insulation that's up there. You can always call in what we call blow-in truck, and they'll just blow in more insulation, either cellulose or fiberglass, to whatever level you want. Just gotta get the truck there and have them go to town.
right, and from the architect's perspective and your energy consultant is And for just like added value to the homeowner in terms of their comfort, it could really be worth it to say, tell your energy consultant, yes, we're gonna, do the QII. And then we're gonna take a look at the HERS verified existing conditions being altered, let them know what you wanna look at. And in this case, it was the attic, construction, and adding in more insulation improves the comfort for the homeowner, but also it can oftentimes give you a credit offset that allows that addition or alteration to do the other things that your client wants, like bigger windows. I keep coming back to that one because that one really seems to be the common,
It is the most
one.
common. Yeah.
Yeah,
They want to
most
have
common.
a 16 by 8 rolling wall, facing south
Yeah,
or west.
exactly.
Right.
Right. Oh, and then I think there's a question in the chat. I don't know if you
Yeah.
can see it, Paul.
See here.
See if it makes sense to add
Let me
when to address
do a
that
little navigating
question.
here.
Maybe
Spray foam.
maybe now, because we're going to talk a little bit about spray foam as an air barrier and some of those things. So, while Paul's taking a look at that, I'm going to give you a little kind of preview on this, the spray foam discussion. Is a lot of times some of the builders are telling us it's very cost effective to use closed cell spray foam as a way to sort of air seal the whole roof deck, sometimes the walls too, air seal everything, and then use the remaining cavity with either a blown in product or batt insulation. And so here's kind of an example, 2 different projects actually, but they could have been on the same project with the 2-inch closed cell spray foam is adhered to the underside of the roof deck on the left, and then that remaining cavity was filled with batt insulation. What is kind of explicitly spelled out in the CF2R form, if you download those forms and have them there as a tool, it'll remind you that the air barrier material, note SPF, which means spray, there's the spray foam insulation, is acceptable air barrier and sealant when installed to a minimum thickness of 2 inches for closed cell and 5.5 inches for open cell. And that's true except where it's not allowed by the manufacturer. For example, you can't use your spray foam insulation around your around flues that get hot, or vents that can get hot, or can lights that are not specifically rated to be in contact with spray foam. And that is in addition to just being an insulation contact rated light fixture or an airtight light fixture. You need to make sure you have that extra category on there, or design a way to keep the spray foam off of the light fixtures. And then here's a kind of example of what that looks like, both for the walls and roof in a particular project that Paul was working on.
Yeah.
Okay,
That's an
Paul.
ADU in Morro Bay that I visited about a month ago. I want to address the question. You want to do that?
Yeah.
So the question is, if do I have an opinion in regard to spray foam on top? So tongue and groove is a unique situation. If it is a tongue and groove and with attic space above, we know that's notoriously porous. If people like the look of TNG, you really want to have some kind of air barrier on the other side of it, then you can apply your TNG. Now, this situation is, say, a non-vented attic where it's a roof deck style, and the intent here is to add insulation on top of that. That's a rare situation around here and would be something you'd want to be careful with because of moisture that could get into that assembly. And so the question is whether or not you would want to spray that, say, sleeper cavity to the point where it would get maybe oversprayed, and then you would shave it down so it would be completely filling it, and thereby you can put your sheathing on top of that, your ply or whatever. Yes, I would agree you have to at least meet the R value. It depends on how thick those sleepers are going to be. But again, I would really want to work with someone who has done this before and that you don't have any possibility of having moisture entering that cavity. I hope that answers the question. Jennifer?
Also, it's important to understand what material the spray foam is, work with that manufacturer, that installer, because in order to have it function properly, to stop the migration of moist air, because it turns out that moist air, just the molecular chemistry of water molecules in air and the atomic weight of water versus all the other components of our air, moist air is more buoyant than dry air. And so what happens is you get a lot of moisture kind of migrating up through our assemblies, up into our roof and attic assembly. So that's why the code says, okay, you got to have an air sealed air barrier just to help prevent that from happening. But like Paul said, T&G is not an air barrier. So now you want that spray foam to really be your air barrier and to seal everything. So that's where you're going to get into, is it closed cell? Is it open cell? You know, medium density, light density, and what thickness do you have to achieve to have it qualify as an air barrier? So I just say that just has to go into it.
Right. I would recommend a closed cell product, and that's what the installer would probably recommend. And then what was my other thought?
And then I think, yeah, go ahead. And we're gonna, I'm gonna click to the next slide, and we're gonna take a look at attics that have blown
open
in.
cell products. The most common one, when they say open cell, it's that Icynene product. And it can really expand a lot and get really thick really quickly. So there's an art to spraying that material into the cavities, and it just, really expands quickly. Then as it cures, it skins over. So it feels like it's kind of closed cell on the surface, but that's just a light skin on an open cell product. You can really tell the difference when they spray the closed cell. It's denser and it's got kind of like a waxy finish to it that you can tell is acting better as a vapor and air barrier. Okay, next.
Okay, so here's an example of what the CF3R for your installation verification would look like. Again, the low-rise multifamily is not going to have these watermarked version of the forms yet because we don't have the HERS registry. But this is what you would look at for your, you'd see that watermark on the form once it's gone through that process. And again, they kind of list out just these requirements on the form. So if you get a draft copy of these forms, they're just, it's a good checklist of all the things you need to be paying attention to and looking out for. And then one of the things a HERS rater does is to look at the actual depth of those blown in products and see, does the average depth meet the density? And if that depth and that density gives you the right R value for the CF1R, and then if it's been met, great. If not, you might have to go back in and add more insulation.
Yeah, in production housing, that's not a huge deal if they're shy on their insulation depth that they're blowing in, because chances are they're going to be in the neighborhood the next day anyway. And I've had to have people come back and what I call touch up because they just were not consistent in the even level of installation to meet the R value.
Now here's a good one. We put this in because this is really a common area that Paul comes across when dealing with the QII and the air sealing, and that is tub shower enclosures. And so we'll basically, the bottom line is that the air barrier, such as like Blue Board, for example, in the bathroom, it has to be tape and sealed and the exterior walls insulated. Then you put in the tub and shower enclosure. That's the way it's kind of spelled out in the process and the codes. And so it becomes a sequencing concern for the general contractor a lot of times to how to deal with this. And then here's a couple of examples that Paul's dealt with on some projects, and I'm going to let him address this. And then once we go through these next couple of slides, then we're going to quickly go through some of the air sealing and the blower door testing, and then finish up for you.
Yes, so to the contractors in the audience, I'm just always amazed how early tubs get set in the building process. So before you get your tub set, and this kind of goes all the way back to the pre-con meeting, is we need to plan for an approved air barrier in between those tubs, showers, what have you, and an external wall, exterior wall. So what you see on the right is just something rather than nothing in terms of a potential go around. There was once upon a time something flying around in our HERS radar world that if you use 2 layers of Tyvek, you could meet the perm rate for an air barrier. I'd prefer to just go ahead and have a layer of thermoply or some other approved material to trap the air behind that tub. On the left, we have another exterior wall. This is a corner installed fireplace. You want to make sure that that fireplace is substantially inside the building envelope. And what we've done here is added some OSB up to about, I don't know, waist high, and then insulation is going to go behind it in theory. So I think maybe what you're looking at is on that one wall where the blown-in net and blown is. That's your exterior wall, and maybe to the left we have another interior wall that has just some bat insulation in it for sound purposes. Kind of hard to tell from this picture. There's no defining, element that says what really it is in there. The point being, though, you want to have the fireplace set after your exterior walls are insulated and air sealed.
Right. So then again, that sequencing, and then another sequencing issue, quote from Paul, I found that certain trades can affect thermal performance in a bad way. Right. So
this is super fresh, just from a job I was on yesterday. A really nice remodel in a Atascadero. And oftentimes when I'm rooting around up in these attics, I see instances where we can blame it on anyone, the cable guy, the HVAC guy, plumber, electrician, whatever. They need to get to certain things to do their work. If they would just please put everything back, it would really help the cause. So this is a pretty common sight up there.
So it's just part of like, okay, if you have your general contractor, it's like, oh, it's like the team captain, and you kind of make it a team sport. You kind of follow up after all the other trades, and give the homeowner, give the client the building kind of envelope integrity that they had paid for, is the way we see it. Then moving on to the building envelope and air leakage testing, and then ways to air seal. And this example of what this equipment looks like. And Paul, I'm going to let you talk about this.
Well, it's a very powerful tool. It can be used for a lot of different things, but the most common is just overall dwelling air leakage. And there's a lot of metrics for that flying around. The current most popular is air changes per hour at a certain test pressure, the most common being 50 Pascal. So the abbreviation is ACH 50. And basically what you're doing is pressurizing your dwelling to a certain pressure, 50 Pascal, which is about inches of water column, 0.3, something like that. Not enough to pop your ears, but enough to at least ascertain what the leakage is. And using other tools, you can figure out where the leakage is. Most commonly, a smoke pen. I carry a thing around in my work truck, which is it's called a pressure pan. And we can go basically to various areas, mostly light switches and junction boxes and so on, to see if there's pathways for air to either to infiltrate or exfiltrate in that dwelling. The new mantra that came along about 10 years ago is build it tight, ventilate right. And so when air is moving, energy is moving with it, right? So you want to stop that process and then have a planned, a predictable form of air movement that provides, say, healthy ventilation for the occupants. That's the upshot of this kind of stuff. Next. So this is what I carry around in the work truck for duct leakage testing. There are other tools you may need to have. I was on a job in Santa Ynez Valley for some really fancy HVAC supply registers. They're called slot diffusers. Some of these are like 12 feet long and all of about 4 inches wide. And so in that instance for duct leakage, I carry a big roll of craft paper that's about 6 inches wide that we just blue tape onto those diffusers. But if I can run around and do this kind of test on your standard 6x12 or 8x14 supply registers, it's an easy game. But the rater needs to verify that those terminations are sealed to the surrounding surface. And in this instance, it's a drywall. And on the left, you can see that even in a popcorn style sealing, we can get a good enough seal to conduct a fair duct leakage test for the project. And you can see various strategies to seal those, what they call boots in the trade. A lot of trades like to use a type of tape for whatever reason. I think just because they don't want to have caulking dripping on the floor if they're not really paying attention, or they want to put down a drop cloth or whatever. The language in the code is sealed to the surrounding surface. I would prefer some kind of caulking material because I think it's just longer lived and does a better job. But if it passes, it passes. But we want to make sure that there's no pathways for that supply air to get itself back into an unconditioned attic. And that's part of the testing that we do there.
Okay, and then from the kind of building energy code side of it, again, kind of coming back to a performance method and maybe the design of energy consultant working with the architect. And often the question comes up, hey, if you need more credit, let's say I'm kind of using the extra big, large windows again as an example and need a trade-off. A lot of times I say, oh, we have to do air sealing anyway. It's a mandatory measure. And you might be doing QII anyway. Can we do envelope testing and get extra credit? And so the default now is 5 air changes per hour at 50 Pascal. So 5 ACH 50, which is a fairly tight house when you consider that some of the houses we've gone to might have leak. It might be like 30 ACH 50. Even though all this air sealing is mandatory measure, it doesn't mean it always happens the way you think it should. So your building's considered to be pretty tight already. And then if you have ducts within the conditioned space, so you're going with a ductless system, that default ACH 50 that you get compared to drops to a 4.4. So kind of give you order of magnitude, we usually are targeting less than 2 ACH to see kind of much of a credit. And what this looks like on your CF1R is the HERS feature summary will show it. It's going to be part of QII, but also explicitly have building air leakage, reduced infiltration called out. And then there's the building envelope HERS verification section where it's going to say, yeah, your QII is required, but your building envelope is required. Then what is the overall cubic feet per minute at the 50 Pascal? CFM 50 is 400 for this ADU example I was doing. And then column 5, it says CFM 50 again, but really that's the air changes at 50 Pascal, and 2 was what this particular example called. And so this kind of a thing, it really, if you notice this on the Title 24 report, you're definitely going to want to bring this up at job site review meeting, and you're going to want to do some pre-tests to make sure you're meeting these requirements and have a chance to go back and air seal things before that final blower door test is done. And I'm going to let Paul mention a couple things, and then we're going to give you some examples of like what some of this air sealing might look like. And we'll,
Okay. Yeah, I just want to mention, can you go back one slide,
yeah,
Jennifer?
Yeah.
Getting down to an ACH 50 of 2 is very difficult unless you really plan for it. There is new strategies showing up for this, and I'm not promoting it yet, but I do want to mention that it's there, and it's basically a way to seal a house using a vapor-driven sealant. It's kind of like blowing like a latex-based or water-based material into all of the spaces into a framed house, and apparently can even be done after it's been drywalled. I believe the product is called AeroSeal, and there is a local contractor in outside of Atascadero that has been doing this. I've yet to go see their demonstration. They've been after me for like 5 years, but apparently it can get your ACH 50 down to nothing. Have to pay for it, but it is maybe an alternative strategy in addition to or in place of the massive amount of caulking and sealing and foaming and this and that may need to be done to get down to those low ACH 50s.
Yeah.
Either way, they're both good, but you should plan for it at the outset. The company that built a huge house up in rural Paso Robles, they asked for a blower door test, but the house itself was over 7,000 square feet. That blower door device that I have can only really get up to about a 5,000 square foot dwelling. So if you're going to try to rope this into a Raider to test and it's greater than that, you'll have to have another blower door, in other words, 2 of them, to get the pressure added up to test that dwelling if it's over 5,000 square feet. Okay.
Yeah, that's great. And that's another reason some folks are moving towards doing that 2-inch spray foam, 2-inch closed cell to kind of air seal everything. They're trying to get that. And then I'm going to give you some examples of air sealing and just kind of what it looks like, some of these more tricky areas. So top picture is from a project I was on. So they've got the expansive spray foam all around the sealed ducts before it's connected into this daylit basement that's going to be conditioned and then going out into a crawl space. And then the U.S. Department of Energy has a great guide for ways to show contractors the proper way to air seal around typical breaks in a ceiling. And so they show like using sheet metal and other cut air barrier materials and how to do that. And then from one of Paul's jobs up on the top, they did a really good job of doing a continuous sealant around the exterior bottom sill plates, and that those sill plates are to be sealed to the floor. And that actually, these sill plates is part of the mandatory kind of measures as part of QII, but a lot of times we're not seeing it done very well. And so this could be really a common place for air leakage. So that's where that aero barrier product comes into play, because apparently it does a really good job of dealing with those kind of leaks. Another method I've seen quite a bit is a continuous gasket between the plate and the concrete. So that's installed on top of the concrete foundation or slab before your sill plate is put in place. And in this particular example, you can see that gasket kind of squeezing out, and then that void there could be filled with a backer rod before they do their final finish. And kind of give you an idea of another common way we're seeing this dealt with locally. These are pictures are both two local projects. You can use like a liquid applied, or it's not really, it's gooey. It's more like a caulking material, but it's called a liquid applied material. You can caulk that out and then, or put it into a trough like the installer is doing here. And you can put that material into place that basically seals up that gap at the base of the plywood and your sill plate. And another detail we're seeing for folks that have maybe come and are learning more about the passive house kind of techniques for building is you can extend your plywood or your sheathing or your zip sheathing long and extend it beyond your sill plate. And so it's important to make sure that plywood material or your zip sheathing material does not rest directly on the concrete. So you'll need a little interstitial bit of self-adhered membrane or other product. And then you can use a self-adhered membrane on your sheathing and actually adhere it to the foundation. And that is, if you do techniques like this, you can get those ACH 50 numbers down to less than 1. And then you start to see some pretty good credit for that.
And Jennifer, I just want to
Yes.
let you know that we have about 15 minutes left.
Okay, perfect. So just give you another example. These are all part of the things that are on this list for air sealing. If you are doing an alteration, for example, in a project, you need to still meet these air sealing requirements, and you might have existing light fixtures in there. So you can either buy a specialized box that goes over the light fixtures, or you can create one out of drywall or sheet metal, but you're going to want to caulk the seams and make sure there's no gaps. And so now you keep the insulation off your light fixture, as well as create your continuous air barrier. And we're going to close with a couple of other credits that really are part of the mechanical systems for credit, and it's called the variable capacity heat pump compliance option. And this really comes into wanting to take credit for using ductless systems, whether ceiling registered or wall mount. The reason we're mentioning it in this part 1 presentation is because this credit depends on those mechanical systems being within the continuous air and thermal boundary. So in this example, it's a wall mounted ductless mini split. and then where the piping that for the refrigerant, the condensate line, and your comm line or communications line back to the outdoor unit penetrate through that wall, that also needs to be sealed, like some of the other examples we showed with the expanding foam, for example. For the compliance option, to able to take the credit for ductless sealing recessed units, then you're going to want to, again, create a continuous air and thermal boundary. So this is where maybe, for example, this section on the left is if you hold the insulation up to the roof deck, and it shows an example with the 2-inch closed cell spray foam and then adding the rest of the insulation, you'd have a clean attic, that ceiling register, and everything is within the conditioned envelope. But if this is a decision that's made, say, after all the construction documents have been worked and they're not going to go back and rework all these details, then you could still get this credit and work this with the energy consultant by creating a essentially a box for that ceiling register that is air sealed and part of the ceiling air barrier, so part of the ceiling drywall, and then adding the same amount of insulation required for the project on top of that box. And again, you'll get that in your thermal boundary. So kind of wrap this thing up. When we're talking to the architects and trying to help the builders understand the project, we're starting to recommend that a project that includes HERS measures, which just about all of them do now, is that we call out some of those major HERS measures right on the cover sheet. And so we're suggesting that it might be included in your code summary section or your code analysis section that you might typically have on the cover sheet. Or in this case, you might have a supporting document section, and under that supporting documents, you're often listing that Title 24 energy report is needed, but then under that saying, hey, note, HERS measures are required on this project, QII HERS, for example, or the variable capacity heat pump credit taken. We're trying to give like, hey, heads up, really you want to take a look at that Title 24, or you might just want to add a HERS summary block on your title sheet. Okay, Paul and I and Grant were available as code coaches. So through 3C Ren, if you have questions, you can get a hold of us and ask us your code questions. Anything you want to add, Paul, before we let Sarah kind of take it over, and then we'll have a couple minutes left for questions?
Yeah, because we only have like 7 minutes left. Yeah, good question on the chat about is whether or not Tyvek is an approved air barrier. As far as I can remember, last time I checked the approved list from the CEC, it was not on there, although I know the Tyvek peeps from DuPont claim that it is. I think it is an approved moisture and vapor barrier if it's, taped and sealed and everything, because it, comes in sheets. And I would suspect if used in conjunction with external sheathing like OSB and ply and so on, that the assembly together can be an approved air barrier. But that may need further clarification just to really nail that the answer to that question.
Right, and then that's part of that whole assembly is plywood. If it's taped and sealed properly, plywood is considered an air barrier, but there are different brands of plywood that you can definitely push air through them, and other brands you can't. And same with the OSB. So there's this huge range, actually, when it comes to in the field testing. And folks will put a house wrap over those products to, just in case, kind of put the whole thing together and improve the performance and try and take care of the fact that all the products, all the sheathing products require some gap as you put the pieces of material together, because there is some expansion and contraction and you have to allow for that. So those gaps have to be taped and sealed really to be called an air barrier. So a lot of times folks consider the drywall on the inside of the house as the air barrier. And so though, if you want to do that, then you're needing to make sure that sill plate is sealed, like some of the examples we showed, but also that your drywall now has a bead of caulking that is set up and at the base, and so that the drywall is actually attached to the sill plate and your top plates, and then all the other rest of the seams you can seal around your light fixtures, your electrical boxes and all that, and tape and seal your sheets of drywall. So that's kind of what we're seeing is when in doubt, they're just calling all that the air barrier. But you're going to want to use some of those other advanced techniques if you're trying to get to like the passive house standard, or to really take credit in the energy performance method as a very tight house. Otherwise, you just follow the QII and mandatory measures and do your best. Okay.
Yeah, and I'd like to add, we don't have all the answers all the time. So, you know, it's always a moving target and we're all continuously learning new things. And so if we can't help you on some of the more tricky questions, we have to go back and do some more homework so that we can, you know, learn ourselves on some of this stuff. So there's a lot of resources out there, and sometimes there's just not enough hours in the day to get it all together into our toolbox.
Okay, Sarah, I'll let you do that closing slide, and then it looks like we'll have a couple minutes for questions.
Yeah. So I am launching a course poll. Today's course is a new one to our catalog. So any feedback that we receive will be really appreciated. It just helps us further develop our course offerings. And that we will have AIA and ICC learning units for today's course. If you need to send me your AIA number or your ICC email address, my email is there on the screen. In the next few days, you'll be receiving your slides, a copy of the slides and a recording. And we also have a different survey in that email. It kind of dives a little bit deeper into just a few questions. I think there's about 4 or 5 questions. And then in February, I've listed out our course offerings. All of those titles are links, so you can click on them when you get the slide and register. And then we also have our full catalog on our website. So with that, we have, about 5 minutes. So if anyone has any questions, feel free to unmute yourself. And we can stay on until about 11.
Or you can put a question in the chat too, if that's easier for you. I think, and while we're seeing if we have any questions, I think kind of big picture, I want to just kind of point out maybe to the architects and the builders on the course that like that variable heat capacity credit for heat pumps, and either ductless or, in this case, ductless, because it's part of that envelope measure. That's worth a lot of credit right now in the Title 24 performance method world. And so that one's definitely worth looking at. So I think as designers want to really design ahead of time whether it's these ceiling registers, recessed ceiling registers, they're square ones, they're slotted, more rectangular shaped ones, or if your clients are comfortable with wall mounted units, to really kind of sort that out, because you could get a lot of credit in there, but that's a coordination. You want to give your builders a heads up. This is what you're planning, and that you need to take that variable heat capacity credit. And then as far as the air leakage credit we talked about, that one, not so much credit for maybe all the work that goes into it. But there could be a lot of payback for your clients just in terms of comfort, better construction, better building, whether or not you're really going to see it on as helping to offset, say, the larger windows. Anything you want to add on that kind of, Paul, is sort of like order of magnitude and big picture to sort of help folks figure out what credits they might go for, and then what that means in the workflow down the end for you?
Yeah, I'd say at this point, used to be blower door testing for credit was more prevalent. Now that's kind of taken a back seat to the equipment efficiencies. So now we're seeing heat pump efficiencies really getting higher and higher. Same even with regular split AC furnace systems. The mechanical stuff is really coming along at breakneck speed. And I just also want to emphasize that once a energy consultant and the architect have come to agreement on what they're going to do, let's rope in your HERS rater as soon as possible so that they can start educating the installers and so on. And please put the required tests right on the front page of your plan set, because so often it gets buried down, and then the site supervisor's like, oh, I didn't know I had to do that. And then you're like, oh, okay, well, here I am being an educator again. So let's get the education out sooner in the build process to help everyone involved.
Yes, absolutely. And we did get a question in the chat speaking about the heat pumps coming up. And then in our part 2, we're gonna hit more on this mechanical HERS side of it, is the part 2. And there is a question in the chat about multiple indoor fan coils on a single variable heat pump outdoor condensing unit. Yeah, that sometimes, yes, there could be some issues with temperature regulation inside those units, but sometimes you need it fine-tuned by the installing contractor. Other times, in my own house, for example, I opted for multiple indoor units and one outdoor condensing unit, and this whole system works a heck of a lot better if I could keep my teenagers to keep the doors open and just let the whole house get to an even temperature when no one's in the rooms or using them. And sometimes they don't want to do that, but when they were younger and we just lived in the house most of the time with all the doors open, it was not really an issue on the temperature regulation. Also, it depends on your solar heat gains through your glazing and kind of the orientation of the house and time of day, because your system may be calling for heat or cool depending on the zone that has the more extreme need. And that can also affect that. So there is stuff to know about it. Let me just say that. And I can't go over the whole thing now, but we could try and hit on some of that in the part 2, actually, coming up. And I see it is 11. So, Sarah, you want to wrap us up? And
Yeah.
Or if there's some extra questions, we could stay on for a minute or 2 longer, but otherwise we want to respect your time and let you folks get on with your day, and thank you. And okay, Sarah, I'll give it to you.
Yeah, if there are any other questions, since we are at time, please definitely utilize our Energy Code Coach service. We can get those questions answered for you. So thanks again all for joining us, and I hope you have a great rest of your day.
Yes, thank you, everyone.
Thanks, everyone.